Hi, my name is Anne Marie Brutus, and my topic is the use of encryption in cloud technology. This is for the healthcare space. Healthcare data security. What is data security? It is more concerned with protecting data that are stored or transmitted between computer systems, as well as cloud systems. Privacy, on the other hand, is considered as one of the main objectives of security. It enforces certain rules and principles that regulate to what extent data about individuals or groups can be accessed, gathered, or transmitted to a second or third party. The Health Insurance Portability and Accountability Act tends to drive the decision making process for this industry and how it handles patient data. Cybercriminals have turned to medical records as their primary source for their nefarious activities. Solutions: use the storage and processing power of the cloud, and not having such sensitive data stored on a local device. Key areas of cloud computing: shared resources. Clients can share resources like networks, servers, storage, software, memory, and processing simultaneously. Providers can dynamically allocate resources according to the fluctuations in demand, and the client is completely unaware of the physical locations of these services. Broad network access. The cloud allows a broad access to the network using the internet from any device. Elasticity. The cloud is flexible and configurable. Clients feel that resources are unlimited. On demand self service. If needed, any customer can automatically configure the cloud without the interference of service technicians. Customers perform scheduling and decides the required storage and computing power. Measured service. Different cloud services can be measured using different metrics. Detailed usage reports are generated to preserve the rights of customers and providers. Cloud computing has four different service models. Software as a service. It is the most popular cloud service, and the software resides on the provider's platform. The consumer can access the software using a web browser or an application programming interface. It pays it uses a pay per use business model. Consumers do not need to worry about the software upgrades and maintenance. Some limited application configuration capability may be available to consumers. Salesforce and Office 365 are popular examples. Platform as a service. It provides development and testing environments. The consumer develops his or her own application on a virtual server and has some control over the application hosting environment, particularly the application and data, making it faster to develop, test, and deploy applications. Cloud Foundry is a good example of this. Infrastructure as a service. It provides the infrastructure, operating systems, and applications. It is the service of choice for companies that do not have the necessary capital to buy hardware. Customers pay according to consumption. Another one is infrastructure is scalable depending on processing and storage needs. The consumer has control over the application, data, middleware, and operating systems, but not over the underlying cloud infrastructure. Amazon EC2 is a good example. Anything as a service. It offers a variety of services ranging from personal services to large resources over the internet. Encryption requirements within HIPAA. Let's start by looking at how we interpret encryption requirements within HIPAA. In particular, those that define the requirements for encryption of data at rest and classify it as an addressable control. This has led some organizations to think that because it's classified as addressable rather than mandatory, they can simply decide not to implement it. However, guidance provided in the HIPAA FAQ published by the Department of Health and Human Services makes it clear that encryption is essentially mandatory. How? Because it would be difficult to determine that it is not a reasonable and appropriate control based on an assessment of risk regarding protecting the confidentiality of ePHI. Also, because of what encryption does to data, finding a reasonable and appropriate equivalent alternative measure is essentially impossible. Encryption options based on data type. There are basically two types or formats of data that need to be considered: structured and unstructured data. Structured data is typically data that is stored in relational database systems, such as Microsoft SQL. Unstructured data is represented by files, directories, shares, as well as some of the newer NoSQL databases, including Hadoop and MongoDB. Whole disk encryption. This method involves encrypting the entire disk, regardless of its content. This is typically used to protect laptops and other portable devices and is designed to protect against physical theft of the device. The process requires that a password be entered when the device starts up and whenever authentication is required, like when your screensaver is activated. Once entered, the actual data on the device is not encrypted and available for use. This is not an effective method for servers, as they are always on, meaning the applications on the servers are always running. Any unencrypted data is subject to loss if unauthorized access is gained to the server or application. In my opinion, this method just doesn't meet the intent of the HIPAA encryption requirements. Database encryption. Many relational databases, including Microsoft SQL and Oracle, have built-in encryption functionality that allows the user to specify which data elements are encrypted. This method encrypts the data before it is written to the database tables. Access to decrypt the data can be tightly restricted so that any person or application without appropriate rights will only see meaningless ciphertext, even while the server or application is running. This method provides true at-rest data encryption and meets the intent of the HIPAA encryption requirements. Agent-based encryption. Several solutions provide a software agent that resides on the server and provides an interface that enables a user to encrypt data regardless of its format, which allows the encryption of individual files, whole directories, and even databases that reside on the server. Similar to database encryption, the agent encrypts the data before it is written to disk and provides the same level of access control to the encrypted data. This method also meets the intent of the HIPAA encryption requirements. Application layer encryption. This method is employed as part of the application development process and results in all encryption or decryption functionality being built into the application that handles ePHI. Essentially, it integrates a crypto library that provides the encryption and decryption functions with an algorithm to encrypt data within the application before it is written to disk. This method can also leverage existing key management functionality that is typically built into the crypto libraries and or integrate with an external HSM or hardware security module for added encryption key security. This method also meets the intent of the HIPAA encryption requirements. As you can tell, depending on what you're encrypting, different at-rest options are available, most of which meet stringent HIPAA encryption requirements. While critical, It's only one part of the equation to ensure your data meets criteria and is well protected. Critical components of encryption. When it comes to rendering data unreadable, you have several methods at your disposal. These include encryption algorithms like AES, Blowfish, 3DES, truncation, and index tokens and pads. The most common method is using an encryption algorithm. There are several crypto libraries that contain full encryption or decryption routines using one or more freely available algorithms that can be integrated into each of the encryption. One-way hashing is another option, but is typically implemented in application layer encryption. The most important consideration here is selecting what is considered strong encryption. Most regulatory requirements mandate the use of strong encryption without providing specific guidance for what that means. Strong cryptography is a general term and applies to cryptographic systems or components that are considered highly resistant to cryptanalysis. This is a complex issue and there is no standard scale for measuring or defining the term. There are certain algorithms that are considered strong by the information security community, including AES and the most popular, and PGP, Blowfish, and Triple DES. Key length is also a factor in determining the strength of an algorithm. For example, AES, a minimum of key length of 256 bits is considered strong. This is for AES. Encryption requirements within HIPAA. Until now, our discussion has focused on encrypting ePHI in storage, but we can't overlook data in transit. Let's turn our attention to securing the transmission of ePHI across open public networks. While protecting medical data in transmission involves many of the controls and practices previously mentioned, additional measures must be taken that depend mostly on the kind of transmission. End user messaging technologies like email, chat, and instant messaging should never be used to send unprotected ePHI. Instead, strong cryptography and security protocols such as SSL or TLS or IPsec are mandatory, with verification that the data is definitely unreadable. Wireless networks involve a slightly different set of best practices. Whenever a wireless environment is connected to the data environment, all wireless vendor defaults must be changed at installation, including encryption keys and passwords and SNMP community strings. Configuration settings should be updated to only support strong encryption for both wireless transmission and authentication. The current secure standard is to use WPA for wireless security. In concluding, the option of using the cloud to process and store healthcare data is a viable option for organizations in this space. Organizations can choose to build their own cloud or use the services of cloud service providers or CSPs such as Amazon, Microsoft, IBM, and Google, to name a few. Securing this data can literally be a matter of life and death. Security requirements must follow a multi layered format. Improving operations with the use of encryption is one of the best tools to combat attacks on this data by hackers. Thank you. In closing, I'd like to give reference to articles that I use for this presentation. One of the articles I used was eHealth Cloud Security Challenges by Al Issa, Autumn, and Tom Rowry. I also use another article called Utilizing Cloud Computing for Stronger Healthcare Data Security by Snell. The next article I also used was Protecting Patient Data in the Cloud, Encryption from A to Z, Parts 1 and 2 by Hagerman. And I also consulted the Gartner Release 2019 Market Guide for Cloud Service Providers to Healthcare Delivery Organization. Thank you and have a good day.